Welcome back. This is our video 26. We are discussing the last of 6 methods. You remember in the beginning, I said
the 1 ohm. The 1 ohm is missing. So.
Where? 4 ohm.
Okay, it's 4 ohms.
Yeah. This is plus minus 9 volts. Thank you very much. I said we are going to learn 6 methods. So far we have learned 5. This is the 6th, which we call nodal analysis. First, let's define what is a node. What is a node? A node is a junction. Is a junction between two elements. A node is what? A node is a junction between two elements. So, now, if that is the definition of a node, if it is a physical class, I normally start by asking my students, how many nodes do we have in this circuit? And many people will say so many things. Some will say 10, some will say 4, some will say 5, some will say 9, some will say 20. Unfortunately, you guys are not with me. I cannot ask you those questions. So, but let me just show it to you that by that definition, let's identify the nodes here. This can be 1, this can be another one, and let's label them. This can be another one. Oh, sorry. What we normally do, let me start again. What we normally do is we are going to identify the nodes. That's the first method. That's the first step. Identify the nodes. So let me identify the nodes. This is a node. This is another node. This is a node. This also is a node. Hello? There's a problem here. Is this a node? Since I've identified this as a node, this point and this point are the same because there is no element between them. A node is a junction between two elements. So when you have two nodes and there is no element between them, they are one and the same nodes. Even if you have 3 nodes and there is no element between them, they are just one node. So this point and this point are actually one node. Two of them are one. You could draw it like this, for example. You can redraw this circuit like this. It will still be correct. Bring this one to 1 point, bring that to 1 point, bring this to a point, bring to a point. It is the same circuit. Nothing has changed. Nothing has changed in this circuit. We can say this is a single node. So this is connected to that, this is connected to that, this is connected to that, this is connected to that. Let me return it to what it was before. I do it like this before, and then like that. Since there is no element here, this point and this point, if you like, you can mark it here. But you should know that this point and this point are the same. Even this point is not a node. This point, let me identify this point with blue. Let me use another marker to tell you that all these points I'm identifying are the same. There's my blue marker. This point, this point, this point, they are just the same. Also, this point and this point are just the same. So let me mark this with red. Let me mark this with red. Let me mark this with red. But my message is that this green, they are the same with this. Also, this green is the same as that. So because we can actually do away with this point. We can draw it like this. We can draw it like this. Pam, and it's the same circuit. The fact that you take the wire merry-go-round does not make it a different junction. So after identifying this, so we have how many nodes? 1, 2, 3, 4, 5, 6, 7. We have only 7 nodes. So in this circuit, we have how many nodes? We have 7 nodes. If someone count all this, they can be saying we have 10. But we don't have 10, so we have 7. So those are our 7 nodes. Then the next step is to choose what we call a reference node. You choose a reference node. You choose a reference node. Reference node. And then, so that reference node will be considered to have 0 volts relatively. That, please pause the video.